have a question for you. Where is the data economy headed? I mean, that's the all-important question that everyone wants to know the answer to. I mean, we're never fully going to know what the future holds, but we can be prepared for all aspects that are part of the data economy. In previous videos by Semiconductor, we went into detail on the topics of data generation, data transport, and data crunching. Now we're going to put it all together and show you what goes on into a full data economy. The first step, data generation. We need to focus on creating a system that is both accurate and repeatable, while also providing the necessary sensor quality and pre-crunching data capabilities. For this, we'll need to incorporate image sensors that provide high resolution with high image quality and uniformity, and environmental sensors that can provide capabilities like temperature sensing across a wide array of conditions, all while maintaining a small form factor. Second step, transporting all this data. For this, a modern data transport system that is reliable, interoperable, and has a long battery life is vital. And different data communication protocols have features that make them better suited for different use cases. We learned that Bluetooth Low Energy is the premier short-range wireless protocol for IoT. It's ideally suited for applications requiring long or constant operation with only short bursts of wireless transmission. For example, this can be used in creating a mesh node for a connected smart office. Bluetooth Low Energy provides an extended range for data transfer due to its multiple nodes, high resiliency and reliability by avoiding a single point of failure, and scalability and repeatability for expanding the network when needed. Zigbee is also a popular low power, low data rate mesh networking protocol for home and building automation, industrial control, security, smart monitoring, and more. If we were developing a connected smart home, we could look at using either Bluetooth Low Energy, like we previously discussed, or Zigbee. Zigbee communications, for example, can manage a connected lighting system throughout all rooms of a home, and also a security system that monitors the front door. We can also design the system to include multiple sleep modes to conserve power. And finally, Wi-Fi. Wi-Fi is one of the most ubiquitous wireless technologies for access. It's being widely used for consumer appliances, home, education, enterprise, and industrial applications. If we were setting up automation capabilities in a factory, we would consider Wi-Fi to build secure high-performance networks to provide access to mobile employees, mobile automation, and control devices. The third topic we discussed was 5G cellular. 5G opens up a world of applications in autonomous solutions with its low latency, reliability, and powerful connections. And three classes of cellular infrastructure supporting 5G you could look at are macro cells, small cells, and femtocells. All right, macro cells. Large towers used for transmitting signals over a kilometer distance, not unlike the traditional towers common for previous generations of cellular service. Small cells, broad category of wireless infrastructure that provides coverage in suburban and crowded urban areas, as well as industrial uses like dense robotic or sensor networks. And femtocells can be found in offices and homes and will eventually be built directly into a building's infrastructure. Typically consume less than 100 watts and can be powered over Ethernet. Once all that data has been collected and transported, we got to do something with it. And that's where the data crunching and storage comes into play. Increasingly, data is being crunched in the cloud, hyperscale data centers where racks upon racks of computers just whiz away. Challenge of all this number crunching is that it takes a huge amount of power, generates a massive amount of heat, and the heat's got to be removed from the data center building, which is a direct cost. Therefore, efficient power conversion is critical to reliable, economical, and sustainable cloud computing. And whether you're designing for an automated storefront, a connected sensor network, a connected lighting system, or an automated factory, Semiconductor's dedicated team of field application engineers will work with you to create the best possible solution. We're Semiconductor. You bring the talent. We bring the tools.